So we have, again, just two expressions here, but the strategy will remain the same. We want to rewrite each of these bases with the same number. And for the left-hand side, let's just focus on the 4. If you want to start this one by rewriting and getting rid of the fraction, you can. You can rewrite 1/4. We are dividing by 4 one time. This is really 4 to the minus 1. And then you can distribute that negative exponent. So if you want, you can do that, or you can just start by looking at 32 and 4 and asking what number, when raised to different powers, gives you 4 and 32. And you might be tempted to say that 4 could be your common base, but 32 is not a power of 4. 4 squared is 16, 4 to the third power is 64, so it skips right over 32. So we can't use 4. We're going to have to use a smaller number. But what you can do is recognize that 4 is really 2 squared. And 32 is really just 2 to the 5th. So both of these bases here are really just powers of 2. So let's rewrite them. And I'm going to rewrite this with the negative exponent. We'll get rid of that first. So we have 4 to the minus 1 to the 9x minus 5 equals 32 to the x plus 8. And we'll distribute this negative to each of these since we have an exponent to an exponent. So you get 4 to the 9x plus 5 is 32 to the x plus 8. And now we'll make our substitution. We know that 4 and 32 are really just powers of 2. So we have that 2 squared to the minus 9x plus 5. Let me make some room here. Equals 32 to the x plus 8, but 32 is really just 2 to the 5th. So we'll substitute 2 to the 5th then for 32 and raise it to the x plus 8. And now we'll use our exponent properties. So an exponent to an exponent, we're going to multiply. So we have 2 to the 2 times minus 9x plus 5. So we will distribute the 2 to both of these. And we get minus 18x plus 10. And on the right-hand side, we'll distribute the 5 to the x and the plus 8. So you get 2 to the 5x plus 40. And let's just make a little bit more room to finish working on this. Now, the bases of each expression are equal, so we can set the exponents equal to each other. So we have that minus 18x plus 10 is equal to 5x plus 40. So let's move all the x's to the right side. So we're going to add 18x to each side. So you get 10 is 23x plus 40. We'll subtract 40 on each side. So you get minus 30 is 23x. And divide everything by 23. So that x is minus 30. Let me rewrite that. Over 23. And this should be our final answer. Now, of course, you want to check this, so pause the video, see if you can plug this back in and get something that makes sense, or just check it using your calculator. And with this value, you can verify that it is in fact the correct answer. So let's move to our final problem here. And this one is slightly different than ones we've seen before, but the strategy will remain the same. So what we first want to notice is that we have 3 different exponential expressions. Of course, we're dividing here. And we want to rewrite them with the same base. So 7 is a prime number, so that's already the smallest possible base that it can be. So we can look at 49 and recognize that 49 is really just 7 squared. So let's replace that with the 49 and use exponent properties to simplify. So plugging this in here for 49, we have 7 squared to the 4x minus 1, and we'll distribute that in a moment, divided by 7 to the x minus 6 is equal to 7 to the 8x plus 3. Now, like I said, we'll distribute this 2, so let's just rewrite it again. We have 7 to the 8x minus 2 divided by 7 to the x minus 6, and this is equal to 7 to the 8x plus 3. Now at this point, we need to use exponent properties to simplify. Now you have 2 choices. You can either use the exponent properties when you have a fraction where the base is the same and you have different exponents. So for instance, if you had 2 to the 4th over 2 squared, if we use just basic principles here, 2 to the 4th is just 2 multiplied by itself 4 times. And we have 2 multiplied by itself twice down below. And you can see 2 of the 2's in the top and the bottom are going to cancel out. And this is just 2 times 2, which is 2 squared. And so the pattern here is that when you have division, you can take the top exponent and subtract the bottom exponent. So this pattern will always hold, assuming that the bases are the same here. Now, that is certainly a strategy we can apply here, or you can multiply both sides by 7 to the x minus 6. And on the left-hand side, they're going to cancel out here. And then it becomes more like the first advanced problem we did where we had multiplication and you would add the two exponents since, of course, their base is the same. So either strategy is valid. Let's use the first one I mentioned where we're just going to subtract because we have a quotient here. So we're going to take this 8x minus 2 and subtract this x minus 6. So let's do that off to the side here and we'll make a little bit of room. So I'll just do the arithmetic up here. We have 8x minus 2, and since they have the same base, we will just subtract the exponents. So minus, and I'm putting everything in parentheses so that we don't make any mistakes with our signs, since we're subtracting this entire expression. If you don't put parentheses, you might end up writing minus x minus 6, but really this negative will distribute and you get 8x minus 2 minus x plus 6. So if you don't subtract the entire expression, you're going to end up with the wrong sign here. Now let's simplify. 8x minus x, that's 7x, minus 2 plus 6 would be plus 4. So now we can rewrite the left-hand side where we have 7 to the 7x plus 4, and this is equal to this side over here, 7 to the 8x plus 3. And now that their bases are the same, we're going to set the exponents equal. So we have that 7x plus 4 is equal to this 8x plus 3. And let's solve here. So let's subtract 7x on each side. So you get the 4 is x plus 3. And subtract 3 on each side, we get 1 for x. And at this point, we'll check our work. We'll plug 1 back into the equation. And for this one, since it's our last one, let's just check it by hand, and especially considering that it's a nice, clean whole number. We're just going to check here. Let me scroll back down just a bit. That x is 1, so we're going to replace anywhere we see an x, we'll replace it with 1. So you get 49 to the 4 minus 1, which is 3, divided by 7 to the 1 minus 6, which is negative 5. And we're hoping this is equal to 7 to the 8 plus 3, which is 11. So we can use some different exponent properties here. 49 is really just 7 squared. So you have 7 squared, and we're raising that to the third power. And we're dividing by 7 to the minus 5 power. So we can put that in the numerator and make it a positive exponent. Really, we're dividing by this expression, and this expression is 1 over 7 to the 5th. We're dividing by a fraction, which is the same as multiplying by that fraction's reciprocal. So that's how the 7 to the 5th ends up in the numerator. And we're hoping this is equal to 7 to the 11th power. Here we have 7 squared to the third. We multiply the exponents. An exponent to an exponent you multiply. And here we have the same base, and we're multiplying the two expressions, so we add the exponents, and we get 7 to the 11th power, which is exactly what we expected. So from here, we can feel very confident that 1 is in fact the correct answer.